Welcome to mechanical tutorial. I am going to teach you different techniques in SolidWorks for mechanical engineers. I am going to train you different modules like surface modeling, sheet metal and enclosure design, product design, plastic components design, reverse engineering and many more tips and tricks in SolidWorks. Hi, today I am going to explain about sheet metal base. Left side you can see the drawing of the folded straight drawing of this sheet metal base component. On right side you can see the component and flat pattern. So this is the component I am going to create. So I am going to show you how to create this drawing for this component in folded straight. And also I am going to show you how to create drawing for flat pattern. So let's start now. So I have taken a new SolidWorks part file and I am going to create a sketch on the top plane. So in order to save the time, I have created a sketch for the base flange. So I am going to upload the drawing in PDF format. You can check the description. So this is the sketch for the base flange. So go to sheet metal module and select base flange. So I have taken thickness as 0.125 and K factor as 0.4 and save it. Now I am going to create one edge flange at this location. And then even I am going to add one more edge flange in other side. Now we have to edit this sketch. So delete this line, may bring it down. And we have to place one inclined line and we have to place one arc and select a 3-point arc, join two lines, 2 points. Now select these two line, arc and line, make it tangent, make it tangent. .25 0.25. So this is 0.3. So the sketch is constrained now. Say OK. So we have to modify the other sketch. So go to other sketch and here we don't have to define with dimensions, simply delete these 3 lines and go to convert entities, select all the 4 lines and save it. See here, and we have to modify some of the parameters like custom relief. In custom relief, instead of rectangle, we are going to provide oblong. So select the oblong. Instead of ratios, uncheck this use relief ratio, and width we have to provide 0.1 inch. And this is 0.02 inch, and say OK. See here, when we see from top view, this is how it looks like. Now I am going to add one cutout. So select this face, go to extruded cut, and make one rectangle. And make it construction. Select 3-point arc. Select this line and this point, make it coincide. Now we have to provide the dimensions. Select these two lines. So this is 2 inches, and distance between these two lines is 1.1, and the length of this line is 1.5. Now we have to select this origin and this point, make it horizontal. Now say OK. So we have to link to thickness whenever we create any sheet metal component. So we have to link to thickness. Say OK. So now I am going to create these two flanges. So select this flange and this flange. See, there is a difference. So we have to modify the sketch. This is 1.25. Select this midpoint and this origin and make it coincide. So we have to constrain this height. So make this construction line and select 3-point arc and create an arc. Now select this line and this point, make it coincide. So this is 1.3 and say OK. So it has been created. Now we have to modify the some of the parameters like relief, and instead of material inside,
we have to select material outside. See here, otherwise it will create an internal relief. So to avoid such problem, we have to select material outside, and we can see the difference in the top view. See here, see, edge is matching here. Instead of that, this bend has to match to this edge. Now I am going to modify this relief. So instead of rectangle, I am going to select oblong. Okay, relief, I am going to select uncheck this value, that is use relief ratio. So here I am going to assign 0.1 and here 0.02 and say OK. So we can customize as per our requirement. So I am giving some random value. Now we have to modify the other flange. So here we don't have to edit these lines, so we have to convert these lines into entities, and we have to trim this. So select trim tool, so select corner trim. It is better to select the corner trim because it makes the closed loop. So power trim, sometimes it will show an error. So now this other flange has been created, and say OK. Now I am going to add these holes. Select this face, go to simple hole and make it through all and say OK. So after selecting this hole, we have to modify this sketch. So the hole diameter is 0.25 inch, and select this center, move near to this arc. We can see one center at this bottom of this circle, place near to this. So it is exactly concentric to this arc. Now say OK. So the hole has been created now. Now I am going to create the other hole. Select this face, select simple hole. So instead of through all, just we simply increase it. This hole size might select blind and uncheck this link to thickness and increase this value, because if you select through all, it will pass through these flanges and may create the cutout feature. So to avoid such problem, we have to assign some distance to this hole. Now this hole diameter is 0.625. Now I am going to constrain this sketch, go to edit sketch. So similarly select this point, move near to this arc and place at this center and say OK. select this simple hole and say OK. So distance we can provide link to thickness at this point, and hole diameter is 0.25 and say OK. Now we have to constrain the sketch. See here. So draw a construction line. Now mirror this hole. So select this entities to mirror, that is a circle, and mirror about is line. Say OK. Now once again select these two lines, two circles, select mirror entities and select this line. So this is 2.25. and this value is 2 and say OK. Keep it in isometric view and save this component. So this is the final component. Next I am going to create this drawing. So select this component from the insert model view. So place it over here. So this is the front view. See, we have to set this scale. So select the sheet, go to properties. So here I am going to select 1:2. Say OK. Now select this view and place with projected view. And even we can place the isometric view. Keep it in shaded view. Now I am going to place the dimensions. Select this base and a circle. So it is 1.25. We have to place this diameter and radius. So we can place as many dimensions we wanted, because so select a center mark and place it over here. In this right side view we have to place these two dimensions. So in top view we have to cover more dimensions. See here, this is 2 mm, this is also 2 mm. This is 1.25. This is 3 inches. See here we have 4 holes, that's why we have to type 4 into x. So the distance between this flange and the center point is 0.98. We have to show this angle also. We have to select none for degrees. This is 0.75 and we have to mention the overall distance. So either we have to show in the top view or front view. So overall distance is 4.63. So we can mention this height also. So this defines the overall size of the component. So this is 3. Next I am going to create drawing in folded state. So select model view, select this component and select flat pattern. See, it is in folded state, so we have to go to flat pattern configuration. See, it is activated, so here we have to unsuppress flat pattern. See here, see the top view. So I am going to create this drawing. So mostly, so we have to rotate this, so 90 degrees. So in flat pattern we have to show it in ordinate dimension. So we have to go to annotation, select horizontal ordinate dimension. So this is the origin. We have to select the end point 0 0, this hole, it is 0.95. So we have to select each and every entity. Here also we have to select this arc. So it's not going to select. So we have to go to sketch and we have to place this point, and even here. Now select this ordinate, right click, add ordinate and select this point and say OK. Now select vertical ordinate. So here we need to select this point. We should be careful. So this is the 0 0. You can add this dimension. So here also we have to add this one point at this location and add ordinate. So wherever we see the holes, two holes, we have to type 2 into x. So I am going to select 1, 2, 3, 4 and 5. So it is 2 into x. Now we have to place the center marks. Always we have to place after the placing the dimensions, otherwise this dimension will go to the dangling and it shows an error. So this is the drawing in flat pattern. See, if font is not visible, we can select all the dimensions at once and we have to go to font and we can increase the font size. See, it is very less, so I am going to select 12. See here, now it is visible. Even here also we have to select all the dimensions. We have to go here and select this point. Or we can customize in the template. See here. So I am going to share this PDF. You can check the description and you can download before practicing. So this is about sheet metal base component. Thanks for watching.